The circle. In this video lesson, we shall look at the properties of the circle and how we can use it to solve some questions. So we'll look at questions from WAEC, exams like the NICO, the JAMB, and the WASSCE. Now let's review the parts of the circle. We have the radius, which is the distance from the center to the circumference of the circle, and we also have the diameter, which divides the circle into two semicircles. Then we also have the chord that divides the circle into a major segment and a minor segment. Now we can also be asked to find the length of a chord, and this is the chord of this sector or this circle, and it is given by 2 times the radius sine theta over 2. We can also be asked to find the length of an arc. So we have this, and we want to find this length of arc AB. It is given by theta over 360 times 2 pi r. Now let's talk briefly about tangents to a circle. A tangent is a line that touches the circle at only one point. So all these are examples of a tangent. Now, whenever a tangent meets the radius or a diameter, an angle of 90 degrees is formed between the tangent and the radius or the diameter. Now, this line divides this angle over here into 2 equal parts. And we also know that since this angle and this angle are 90, then the remaining angles must add up to 180 degrees. Now, angles in alternate segments. If you have 2 chords that are meeting a tangent, we can connect a third chord so that we can form a triangle like this. Now, the angle over here, angle A, is equal to the angle that the chord makes with the tangent is equal to the angle in the opposite segment, which is in the interior of the triangle. And also the angle over here is equal to the angle in the alternate segment. Now if you have a chord, this chord can subtend an angle at the circumference, and this arc can also subtend an angle at the circumference. So the angle subtended by the chord is A at the circumference, and the same thing applies to the arc at the circumference. Now this chord or this arc still subtends an angle B at another point on the circumference. Now the angles in the same segment are equal because this angle and this angle are in this segment. They are equal. They are in the same segment, therefore A is equal to B. Now, angle at the center. If we have a chord that subtends an angle theta at the center and another angle alpha at the circumference, then the relationship between the angles is that theta is equal to 2 times alpha, or alpha is equal to half of theta. We shall look at how we will use this in an example very soon. Let's talk about the cyclic quadrilateral tool, then we solve some past questions. If you have a quadrilateral that has its 4 vertices on the circumference of a circle, then we have these angles, the opposite angles will add up to 180 degrees. So angle A plus angle C will give us 180, Likewise, angle B plus angle D will give us 180 degrees. Now let's take some examples. So this is from JAMB 2004. We have this one over here. P, R, and S lies on a circle. Center O as shown above, while Q lie outside a circle. Find angle PSO. So we are calculating for this angle over here, and we are going to use the external angle theorem, that is angle 20 plus 35 will give us this angle, which is the external angle over here. So angle BRS is equal to 20 plus 35, and that is going to give us 55 degrees. So this angle over here is 55 degrees. Now we know that this angle is at the center of the circle, so it's going to be twice the one on the circumference. So angle POS is equal to 2 times 55 degrees, and this is going to give us 110 degrees. So this angle over here is 110 degrees. Now you know angle PSO plus this one, which is the base angle of isosceles triangle SPO, plus 110 degrees will be equal to 180 degrees. That is sum of angles in an isosceles triangle. Now angle PSO is equal to angle SPO, so we can write 2 times angle PSO equal 70 degrees, and this will give us 35 degrees. So we have this a chord XY of a circle with center O and radius 5.3 centimeters has angle XOY equal 140 degrees. What is the length of the chord to the nearest centimeter? So we know the length of a chord is given by D is equal to 2R sine theta over 2. So we substitute the values. We have the radius is equal 5.32, so we have 2 times 5.32 times sine theta over 2, which is 140 over 2. Now we simplify this to obtain 9.998 centimeters. To the nearest centimeter is 10 centimeters. Let's take another one. So we have in the diagram, O is the center of the circle, angle UOT is equal to 70 degrees, and angle RST equal 100 degrees. Can calculate angle RUO. Now we know this is the angle we are looking for. Now we need to determine the base angles of this isosceles triangle. So let's call them X, and this one too is X because they are equal. So we add them and we have 2x plus 70 degrees equal 180. That is from isosceles triangle UOT. So 2x is equal to 180 minus 70, which is 110 degrees. Therefore x equal 110 divided by 2, which is equal to 55 degrees. Now this angle over here is opposite to that angle, this whole angle. So, and it is a cyclic quadrilateral. Therefore the opposite angles of this angle will give us 180 degrees because it's a cyclic quadrilateral. So we have angle RUO, plus 55 degrees plus 100 degrees, which is the opposite angle, equal 180 degrees. So angle RUO is equal to 180 minus 155 degrees, and that will give us 25 degrees. So the correct answer is 25. We have an arc of a circle subtends an angle of 75 degrees at the center of the circle. If the diameter of the circle is 7 centimeters, calculate the length of the arc. So we know length of an arc is given by theta over 360 times 2 pi r. So we just substitute the values. We have 75 degrees over 360 times 2 times pi, which is 3.142 times the radius, which is 7 over 2, and all this will give us 4.58 centimeters. So the correct answer is A. We have this one from Bosse 2009. In the diagram, PR is a tangent to the circle, and the center of the circle is O, and angle OQT is 48. Find angle OTU. So we are calculating this angle. Now we know the tangent and the radius or the diameter will make an angle of 90 degrees. So this angle over here, which is angle P, angle RQT is equal to 90 minus 48, and that is giving us 42 degrees. So this angle is 42 degrees. So this angle is equal to the one in the alternate segment over here, which is also 42 degrees. Now these are the base angles of triangle OTU. Therefore, angle OTU is also equal to 42 degrees.